right, so the first thing we're going to talk about is naming polynomials. But before we start into the technical stuff, I want to just talk about this word, polynomial. Do we know what the prefix poly means? Just in general. What is it?
Shape.
When we talk about polygons, in geometry, polygons are shapes, but the poly refers to something about the shapes. Yes? One more time? Many. Many. Poly means many. And nomial literally means name. So polynomial means many names. And the reason we call them polynomials is because generally they have several things added together. So this means many names. Now, a monomial is a special kind of polynomial. And it tells us on the note sheet, a monomial, well, first off, what does the prefix mono mean? Or mon? One. So monomial means one name. So a monomial is just going to be a number, a variable, or the product of a number and variable with whole number, and I'm going to add something here, positive exponents. Another way that we can think of a monomial is one term. When we talk about combining, we'll talk about combining like terms today. A monomial is one of those terms. So an example of a monomial, 23. A number is a monomial. A variable, x, that's a monomial. X to the fourth is a monomial. We have whole number, positive exponent. We could have a product of a number and a variable. Negative 3x to the fifth. That's a monomial. It's one term. We could also have x squared over 4. That's a monomial because we can think of x squared over 4 as 1/4 x squared. So it's a product of a number and a variable with a whole number, positive exponent. So all of those are monomials. One term. Not monomials. 1 over x. Because we can think of 1 over x as x to the negative 1. So this has a negative exponent. The third root of 3x squared, I'll say, is not a monomial. Because we can think of the third root as a fraction exponent. And we don't want fractions for exponents. So these are not monomials. All right, we good with the idea of a monomial? And your book will refer to monomials in various ways. We just need to know when they talk about a monomial, they're talking about something like this. All right, a polynomial is a monomial. So a polynomial can have one term or the sum or difference of monomials. So we're adding a bunch of these together. So a polynomial, examples of a polynomial, x plus 5. That's a polynomial. We have two terms. But we could also just have a monomial, y to the 6th. That's a polynomial, and it's also a monomial. Usually for polynomials, we have something like 3 x to the 5th minus 4 x to the 4th plus 5x to the 3rd plus x squared minus 6. That's a polynomial. We have a lot of terms, but all of our exponents are positive, and we're adding a bunch of those, adding or subtracting a bunch of those together.
I have a question.
Yes.
Your exponents have to be positive at all times, right?
Positive at all times, yes. Polynomials always have positive exponents. And then just below that, I'm not going to grab a picture of the next little line. Not polynomials. This is on your sheet. Not polynomials. 1 over x plus 5. That is not a polynomial. We have two terms in the denominator, but because they're in the denominator, that is not a polynomial. X squared plus a square root of x minus 3 is not a polynomial, because even though we have the x squared and the minus 3, we have the square root of x. And that makes it not a polynomial. And someone in the other class asked this question. I thought it was a really good question. They said, what if it was something like this? Well, there's a number and there's an exponent. But this time our exponent is the variable. It's not a whole number exponent. It's a variable exponent. So that would not be a polynomial. All right, so a polynomial is just a bunch of, generally, a bunch of monomials added together. But a monomial can also be a polynomial. And our exponents are always whole number, and our exponents are always positive. Okay, let me grab the bottom of that page, and we'll talk about that. Oh, no, we need to talk about the degree first. So we refer to polynomials in a couple of different, we use a couple of different ways to talk about them. One of them is their degree. For a monomial, the degree is the sum, that means add, the exponents of the variables. And I'm going to add a little note out here. The degree of a number is 0. Without a variable. So, example. There's a monomial, x. Well, when we don't have an exponent written here, what do we say? What do we visualize that exponent is? 1. So we think of this as x to the 1. So we say that is first degree. You could also say degree 1, but we usually say first degree. If we had something like x squared y to the third, that's a monomial, just one term. We would say the degree is 3 plus 2. So we'd say fifth degree. If we had something like 3x to the sixth, this is the sum of the exponents on the variables. So we don't worry about the exponent on the 3. We would say this is sixth degree. So we'd say this is a first degree monomial, a fifth degree monomial, a sixth degree monomial. And if we had something like this, 23, we'd say that's 0 degree, degree 0, 0th degree. Yes?
It doesn't matter what the base is, so like...
Doesn't matter what the base is.
Okay.
We only count the exponents on the variables. Now someone asked in the other class another good question is, well, what if we had something like 7 squared? And we wanted the degree of that. Well, I have an exponent there. But this says we only count the exponents on the variables. And anyway, 7 squared we know is just 49. That's just a number. So we would say that's 0th degree. All right, we good with the degree of a monomial? Okay. We use the degree of a monomial to figure out the degree of a polynomial. The degree of a polynomial is the highest degree monomial. So if we had x squared plus 5, well, the highest degree of each term, well, this is second degree, and this is 0th degree. So we would call this a second degree. So we call this a second degree polynomial. Polynomials with 2 terms, we give a special name. We call it a binomial. Because the prefix bi means 2. Now it's fine to call it a second degree polynomial, but sometimes we're more specific and we say it's a binomial. It has 2 terms. I'm going to do this. X to the 4th plus 2x plus 5. The highest degree monomial, what is the highest degree there? 4. So we'd call this a 4th degree polynomial. We also give a special name to polynomials with 3 terms. we would call this a trinomial. Because the prefix tri means 3. Yes? Trinomial means there are 3 terms. So there are 3 parts that we're adding together. That's the part that we're talking about, the tri. The 4th degree just talks about the highest exponent. Let's look at a couple more. All right, so our highest degree on any of those terms is what? 3. The exponent is 3. So this would be a 3rd degree polynomial. And usually above 3, we just, after trinomial, we just call them polynomials. All right, so now we have a chart below there. Yes?
Why do you add the exponent?
We only add the exponents on if we're talking about the degree of a monomial, of one term. So let me show you an example there. We won't see polynomials like this very much, but you probably will in Algebra 2. You might see a polynomial that looks like this. Well, here this monomial has degree 4 because we add the 2 and the 2 together. So we would call this a 4th degree polynomial.
Wait, why?
So this term, this monomial, we add the exponents to figure out the degree. So this term would have degree 4, 2 plus 2. Yes?
So why would we do it with the other one?
Which one?
The 3 x to the 3rd plus 2x to the 2nd.
So these are added. So these are 2 different terms. These are multiplied, so it's 1 term. So we don't combine different terms. We only look at things that are a single term to figure out the degree. Okay? Yes?
I'm just confused how you would give it a 3rd degree. On the one below that.
This one?
Yeah.
We
Right, but okay, so only when you're multiplying it do you add the exponent.
yes. Yes. Yes.
Just like if you had 2 numbers and they were on different equations, but you just choose which one was highest exponent.
Yes. Mm-hmm. Go ahead.
Why would you multiply from that one on the very bottom?
Because we said that's how we come up with the degree of a monomial, the degree of one term. We add the exponents to come up with the degree. What's that?
I thought that was a polynomial for the
Well, to find the degree of a polynomial, we figure out the highest degree of the monomials that make it up. So the degree of a monomial we find by adding the exponents on the variables. So this is one term, one monomial. The degree of this monomial is 4, and that's the highest degree. All right, so let's look at that chart that's below there. Oops. So here we have several examples. first thing it says up here is the standard form of a polynomial is that we always write it in order from highest degree to lowest degree monomial. So, for example, we would always write something like 5x to the 5th minus 3x to the 4th plus 2x to the 3rd minus x squared minus 6. We always, in standard form, we always go from highest degree to lowest degree. So here we have degree 5, degree 4, degree 3, degree 2, and degree 0. Standard form, we go from highest to lowest degree of the monomials that make up our polynomial. And usually we like to write our polynomials in standard form. All right, so here's a polynomial. Our polynomial is a number 2. We're going to fill in this chart. How many terms do we have? 1 term. What's the degree? 0. Special notes? No special notes here. Oh, I could say this is a monomial because it's 1 term. All right, the next one, x plus 1. How many degrees, or how many terms do we have? 2 terms. Degree?
0.
Remember the exponent on this variable we think of as 1. So that'd be the first degree. And for a 2-term polynomial, we call it a binomial. It's not incorrect to call it a polynomial, but we also refer to it as a binomial. Now I want to add one in a different color here. X squared plus 1. How many terms do we have here? 2 terms still. What's the degree? 2. When we have a second degree polynomial, sometimes we'll refer to that as a quadratic. A second degree polynomial sometimes we'll refer to as a quadratic polynomial. Yes?
Well, we need to identify what kind of polynomial it is on our test.
Yes, that will be part of it. And also part of it, they'll say, if you say you have a quadratic polynomial, and you'll need to know, oh, they're talking about something x squared. Do you know that that refers to a square, a degree of 2? Yes.
How do you make the x squared?
I just made this example up.
Oh.
Yeah, this is just another example of a polynomial with 2 terms. X squared plus 1 has 2 terms, and is degree 2. All right, the next one. X squared plus 3x minus 5. How many terms here? 3. The degree? 2. Highest exponent here? We would call this a, because it's second degree, quadratic, trinomial. Quadratic because it's second degree, trinomial because it has 3 terms. Yes.
So binomial refers to when there's 2 terms.
Yes.
The exponent.
Not the exponent. Yes. Yeah.
The only time that you would talk about the exponent would be when it's quadratic.
Well, we give things like this a special name. We call this linear.
And then we wouldn't write that.
You might say it's a linear binomial.
Oh, okay.
Yeah, it's less common when you're talking about polynomials, but you sometimes would hear that this is a linear binomial.
And then just those 2, or is there?
There's more. That's why we're going to keep going. All right, how many terms do we have here? 4. What's our degree? 3, the highest exponent. We're going to call this, because it has degree 3, we're going to call this cubic. So this would be a cubic polynomial. Cubic because it has degree 3. It's not incorrect to call it third degree. Third degree and cubic mean the same thing. Except if a police officer is asking you a bunch of questions, you don't say that they're giving you the cubic. They're giving you the third degree.
Or your parents, you would want to say that to your parents.
Yeah, if you said that to your parents, you'd probably get in worse trouble. All right. This one, how many terms? 5 terms. What's our degree? 4. Highest exponent is 4. Sometimes we'll call a 4th degree polynomial a quartic. So a 4th degree polynomial is also referred to as a quartic. That's less common, but you hear it sometimes. And I'm going to do one more. I'm just going to add one. All right. How many terms here? 4. The degree is 5. Sometimes you'll hear a 5th degree polynomial referred to as quintic. So this would be a quintic polynomial. 5th degree is probably more common, but you will hear quintic. And above 5, then we just talk about 6th degree, 7th degree, 8th degree, 9th degree, 10th degree, etc. All right, questions on our classification. And you might see a question that says, write a cubic polynomial that has 3 terms. And you would say, okay, cubic means 3rd degree, so the highest exponent is 3, and I need to write 3 terms. That's how this classification comes into play. All right, the last thing we're going to talk about today, I think this is enough examples of standard form and classifying polynomials. So there's a blank on the back of your page that says examples of standard form and classifying. All of these polynomials that we put in our chart are in standard form because they go from highest degree to lowest degree. So these are all in standard form. And we talked about the classification. So I think we're good with the standard form and the classification. So let's talk about the last thing for today, adding and subtracting polynomials. And we've already been doing this. We actually know how to do this. So what we're talking about next is not going to be new. We just might have more terms that we add or subtract. But big picture, we combine like terms. To add or subtract polynomials, we combine like terms. And just as a reminder, like terms means same variables and same exponents. That's how we figure out if it's a like term. Same variable, same exponent. So let's look at some examples. Let's say we want to add 3x squared plus 2x plus 5 plus 4x squared minus 5x minus 6. The problem might say add these two polynomials instead of writing it as an addition problem. We're just going to combine like terms. So I'm going to combine the 3x squared with 4x squared. I'm going to combine the 2x with a negative 5x. And I'm going to combine the 5 and the negative 6. So I think to myself, 3x squared plus 4x squared. Well, 3 and 4 is 7x squared. 2x minus 5x. Well, 2 minus 5 is negative 3x. And then 5 minus 6 is negative 1. Now we can also do this, for some people this helps, by stacking them. And by stacking I mean just put them on top of each other like we did when we were in elementary school or middle school and we added big numbers together. And I put the like terms right on top of each other. And then I stack them, and I add. Well, 3x squared plus 4x squared is 7x squared. 2x minus 5x is minus 3x. 5 minus 6 is negative 1. And I get the same result. It's just a different way of looking at it. All right, let me look at another one, and we'll talk about subtraction. We're going to add 3x to the fourth minus 2x plus 5, and we're going to add that to 2x squared minus x minus 3. And I want to combine like terms. So this 3x to the fourth, do I have anything over here to match it up with? No, there's nothing with an x to the fourth. So that just stays by itself. The negative 2x, I combine that with the negative x. And the 5, I combine with the negative 3. So this 3x to the fourth just stays because I'm adding 0 to it. Negative 2x minus x is minus 3x, and 5 minus 3 is 2. Whoops, I forgot something. What do I do with this 2x squared? Is there an x squared to combine it with over here? No. So I just have to have it by itself too. And I write my answer in standard form. 3x to the fourth from here, the 2x squared from here, the negative 3x from combining the red ones, and the 2 from combining the green ones. Yes?
Does it have to be in order for degrees, like the highest exponent to the lowest?
If we want it written in standard form, if the problem says write your answer in standard form, then yes.
And that means the order.
Yeah, the order, highest exponent to lowest exponent. I would say 99% of the time in the book, and when you see it anywhere else, it'll be written in standard form. All right, let's look at a subtraction example. going to subtract these two polynomials. Now we're going to do this two ways. We'll do the combining like terms way, and we'll do the stacking way. When we have a subtraction problem, what I'm going to suggest that you do first is distribute this negative. Because we can think of this as -1 times this parentheses. We've done this before. We're going to distribute that negative first. So I get 2x to the third minus x squared plus 5x plus 3 minus 3x squared minus 2x minus 5. I'm distributing the negative to each one of these. And now I'm going to combine my like terms. Anything to combine with the 3x squared here? No. So we just have 2x to the third. 2x to the third. I have a negative x squared and a negative 3x squared. So a negative x squared minus 3x squared minus 4x squared. 5x minus 2x. 5 minus 2 is 3x. And then I have a 3 minus 5. 3 minus 5 is -2. So if we're going to do the distribute method, we distribute the negative, or the combined like terms method, we distribute the negative and then add everything together. Combine our like terms. If we did this by stacking, 2x to the third minus x squared plus 5x plus 3. And we're subtracting. And I'm going to line up the like terms. So I don't have anything in this parentheses to line up with the 2x to the third. So I'm going to put a 3x squared here under the x squared. I'm going to put my 2x under the 5x. And I'm going to put 5 under the 3. And I'm just leaving this blank. Subtracting is a little trickier because I have to remember I'm subtracting. 2x to the third minus, I can think of this as 0. I just get a 2x to the third. Negative x squared minus 3x squared minus 4x squared. 5x minus 2x is 3x. And 3 minus 5 is -2. I get the same answer. Just a different way of setting it up and looking at it. But remember, with subtraction, you're subtracting everything. Yes? Yes. All right, questions on polynomials and monomials and degrees and terms and names? Okay. We're in section 8.1 and we're on page 489. Two through 40 even. And we have a little over 30 minutes. You can easily finish this homework assignment. Yes? Evens, yes.